Hi there. Thanks for joining program this week on day 3. I hope all are good and safe. For those who don't know me, my name is Maria de Los Angeles, and you can call me Maggie. And I'm a .NET full stack developer and a community lead at Cognizant Softvision. And I've been here for almost 2 years, and I'm really excited to be part of this years of programs week. And talk about Azure Service Bus. So I encourage everybody to ask your question in the chat so I can answer accordingly. And I'm going to answer at the end of the presentation. So yeah, without further anticipation, let's get started. In this occasion, we're going to talk about Service Bus. I'm going to talk what it is, what can I use, when can I use it, and explain a little bit about the patterns and protocols that are behind it. So before turning out our engines, let's start with the basic and have a little quick overview about Azure. So what is Azure? First, Azure is a Microsoft cloud-based platform, and is a cloud services that you can admin your application and services. What do you mean? What do I mean with admin? You can basically create, test, deploy, and manage your product or services inside the platform. It's oriented to cloud architecture and has a lot of services, for example, Service Bus, that can help you with those tasks. There are a lot that Azure can cover, and this is just a quick overview to be everybody in the same page. But take in account that Azure is really good to manage scalability. There is a main concept now in cloud architectures. We are going to pick that point during the presentation. So let's start. What is Azure Service Bus? Let's talk about more in details. So Azure Service Bus, as I mentioned, is one of the many services that Azure has available. They provide us a simple solution to manage our messages between applications. It would work as a broker in which we have messages and queues or topics, depending on our scenario, to do this interaction. And about everything we're going to talk about later in a few more slides. But in simple words, Service Bus is a reliable cloud messaging as a service and simple hybrid integration. There are a lot to cover in this sentence, but to understand it better, I wanted to bring two key concepts that are AMQP protocol and the pattern publish subscriber, that are the main keys to bring all the magic here for Service Bus. So let's start with the protocol. The AMQP protocol is this is the main protocol that Service Bus is based on, and this protocol is all about messaging and communication, and stands for Advanced Messaging Queuing Protocol. This protocol is an international standard approved by the ISO, the International Organization for Standardization, and the AEC, that is the International Electrotechnical Commission. This protocol can help you to create robust and cross-platforms application. And it's really flexible and allows to integrate with all kinds of applications. And before to continue, I want to explain why this protocol is so important and the main reason that it was created. So to understand that, let's talk about back in the old days when we have different problems that this protocol solves. Well, back in the old days, when you wanted to send or receive messages between your application, mainly you have two options. One is to create everything from scratch. That is sometimes not a very good option because you don't have lot of time to do that. And the second is to pick a provider that helps you with that development to reduce some time and make it easier. But every time you choose a provider, you're going to stuck with it, and you will be attached to them for all the changes or modification that you will need in the future. So one main common integration issue is provider dependency that this situation creates. So what do I mean with provider dependency? Mainly your architecture, your language, and your changes will be depending if the provider has everything that you need. So for example, if there is a new version of .NET and you wanted to update your solution, your application, but your provider doesn't update their library, it's possible that you cannot make that update. So that was one of the bottleneck that before we had in this kind of situations. And also all your business logic with your code will be mixed and attached, and it will be difficult to maintain or have it separately. And another common problem with this scenario is that it will be difficult to find a qualified person to maintain or update or add new features to your program, because since everybody is doing the integration by themselves, and there isn't any common library or protocol, you need to find very specific person for each program. So that was another main problem with this scenario. Well, to avoid these dependencies, and a few more that we are going to talk later when we talk about the benefits, more than 20 companies in 2008 began to develop this protocol. There were a lot of companies, from tech provider to retail users. We are seeing here in screen. So everybody team up to start solving the mentioned problems. Some of them gather all the requirements, another create the code and test it. So it was a really big development, and lots of companies were involved. So in this case, the main goal was to delete this provider dependency in your chosen provider. So, well, talking about the benefits of the protocol and also some problems that the protocol solved. Interoperability. This is related to the how you can connect with different languages or different operative system. Before, if you choose something and you write it everything in .NET, you need to connect with another application that understands .NET. Otherwise, you will have you will have compatibility issues. So this protocol solves that, and also you have less chance of vendor lock-in, because everybody will use that protocol and you will not be stuck with the provider you choose or depending on it. Broad availability of libraries and tooling. Since everybody were developing with the same base and using the same protocol, it will be easier to create flexible libraries to accomplish different things that you want to create with your program. Also, protection against obsolescence. Well, since again, will be a protocol that everybody is going to use, and is a standard. You will have the how can I say? You will have this protection, right? Because you will not be stuck with the same provider. Availability of knowledge stuff is related to everything is related to the same point. Everybody will understand and know the protocol because it will be a base. So that is handy. and lower and manageable risk. Again, since you will not be stuck with a provider, you're going to have lower risk to have an available application during the time. So now let's talk about some technical features that this protocol has. One is efficiency. When we talk about efficiency, we're talking about how this protocol can resolve very fast the calculation, right? It's a connection-oriented protocol and use a binary encoding for make this interaction between the business and then transfers the transfer data. So yeah, it implements very sophisticated workflow control scheme to maximize the utilization of the network, and when he connects or they connect with the different protocols. Another technical feature is reliable. When we talk about this item, is to be sure during all the communication of the message that you're going to transmit, know all the steps and don't miss any message during the way. So for that item, this protocol is very good, doesn't miss any message. Also is very flexible. When we talk about flexibility, we're referring about network topologies. This protocol can connect with all the types of network topology that you can find. You can have connection between client to client or client to broker or even broker to broker. So it's really flexible in that area. And last but not least, broker model independent. The protocol doesn't specify any type of model that you need to transport your message. It will be free of that. You don't need any specific model to transmit the information. We're going to see that in or at the end when I show a little bit of code. So yeah, and well, I think this is a, a fast overview about the protocol. There's a lot also they can cover, and it's very powerful. So you can check that in Microsoft Page. There's a lot of information too. And I want to mention too the PubSub pattern that also is another key concept for Service Bus. So let's continue with that. This pattern is frequently used in cloud architectures and for communication systems, also called PubSub, and is an asynchronous messaging pattern for reliable and scalable systems. Again, every time we talk about reliable and scalable, we're talking about don't miss any message. And for scalable, to maximize your resources uses in your servers. So Azure is really good with that feature. You can grow or shrink your resources depending of how many users consume your application. So for that is really good. And yeah, since most of the systems are in or are migrating to cloud infrastructure, also this pattern helps you to decouple your applications and your business logic. So there's a few points that I want to highlight for this pattern. One is the sender and receiver do not know each other. The sender will send the message and the receiver will receive it, but they don't need to know each other. And this is also another key point, because you don't have to have your program or your system available 100% of time. We're going to have a little demonstration with the code at the end too, but you can send the message. The message will be stored in a queue or topic, and then when the receiver is available, it will pick up those messages. So another key point for topics or subscribes, is that the send will send the message one time, and every subject will receive it. You don't have to send the message for each topic that you have in your system. So those are like there are a few things more that the patterns bring, but for this occasion I highlight these two. So yes, now we can continue with more specific with Service Bus and all the thing that it has in the application. So let's talk about some concepts and terminology about the Service Bus. First, we have the namespace that it will work as a container inside Azure. Sometimes they compare it as with a server, but it's not a really accurate comparison because a namespace is not a server, but it can grow or shrink depending of your user usage, the thing we talk about as of scalability. So that's why sometimes is compared to that. And in another hand, we have the messages. The messages are also a container, but they will have two parts. One, it will contain what kind of message you're transporting. If it's a JSON, an XML is a plain text, you need to specify that. And the second part will be your message, the actual data that you're going to send. And this is also a key point that the protocol brings, because it gives you a freedom to send any type of message. You're not attached to send only JSON or only plain text. You can send whatever you want. Another concept that we have in Service Bus, we have the sender that will be like your trigger point or your starting point in this in your application, and you will have the receiver that is going to pick up the message and do certain operation with it. And next we have the queues, that they're going to be the places in a very speak of where the message is going to be stored. They work with FIFO rules. That means that first in, first out. So also they are ordered by timestamp in of the arrival of the queue. So that's another point. And the next one is topics. This is the implementation of the PubSub pattern that we just saw. And for one hand, you have the sender and you have all the different topics. You can have a relationship between one and n. You can have more than one topic related to one flow. And here you have a lot of flexibility on how you can connect your flows and how your application interact. You can make the sender send to one topic and then make another service and connect several queues with topics. Yeah, here you can do almost whatever you want. Okay, I think we review all the main concepts that Azure has to understand it better. So I think we are now ready to buckle up and go to see Azure Portal, and let's see where everything is. So I wanted to stop this presentation and I'm going to go here. This is Azure Portal. We have here the dashboard, and we have all the messages. I mean, all the services that you can find. There's a lot. And for this occasion, I create this namespace. That is the container we just saw. That will store all my queues or topics depending of on how I structure my application. And for this, you need to set up a name, and then you're going to have here some stats on how the queues or topics are going. You have different information here. And in the left, you have below entities, you will have queues, or if you create topics, you will have here the item topics. So let's start. Let's enter to the queue. I create one just to make an example. It's go beyond. And let's see first all the properties that a queue can have. You can assign a name first. And this name must be unique under the namespace that you have. You can have some sizes for the queues in this case. Also, this is applicable for topics too. You can have a maximum of delivered or messages going to enter to the queue. And you also can have these more properties that you can set up. This is the time the message will be stored in the queue. So in this case, the message will last 14 days until the receiver can pick it up. And yeah, you have different properties here. Now let's enter to the queue to see how it looks like. We're going to have more stats about the specific queue. Also, we are going to see the property that we just set for the queue, the maximum delivery count, the current size is, well, now we don't have any message, so we don't have any size here. The max and, well, all the things that we just set up. Another important thing that I didn't mention, but it's really important to be able to connect with our queue, is the shared access policies. Here, you need to create a key in order to connect with the queue or your topic. So when you create, you have available 3 roles. You can create a key only just for send message or just for listen, or maybe both. You can manage that as you want. I just create a few just to make some tests. And yeah, we have the namespace, we have the queue. I think, yeah, we're ready to now take a look on the code and see how this interacts. So let me bring my little demonstration. I create 2 console applications and to demonstrate and make this interaction with the queue. We have in one hand the sender and another the receiver. So let's check about first the sender and how we can set up everything for Service Bus. Well, first of all, in both projects, I install the Azure Service Bus package. You need it in order to be able to connect. And here we have the integration with the MQTT Protocol. So that's the one who brings almost all the magic, and a lot of another DLLs to help us in the process, right? Both have the same package. There was an update last year since Microsoft is migrating everything to .NET 5 and make that big integration between all the products and DLLs and everything. Last year in November, I think there was an update for this package to align with that migration of Microsoft. So if you have any old version, you need to check the documentation to see how you can update properly that package. So yeah, let's continue with the code. I'm using that package, and then you have 3 items that are really key. in order to be able to connect with the queue. One, it will be the service bus connection string that you will pick it up from the keys. Let me go back and go to the share access policies. Every time you create any key, Azure it will give you some values, and you have the primary key, the secondary key, and this connection string. So you will pick it up this value from here, and you will use it in your application. Then you need to have the name of the queue. In this case is Go Beyond. And then you have to create the queue client interface in order to make in order to send the message. The only difference here is if you are implementing a queue, you're going to have an IQ client interface. But if you are creating or you're integrating a topic, you have to create this topic client interface in order to connect with the topic. So yes, we have our connection string, we have our name, and we have our interface. And now when the program starts, I create a small array of strings to make this example and to send some message. But here you can send whatever you want. And I pick up the array, and then we're ready to send the message. I forget this part, the new instance of the queue client. In this part, you're going to get the instance with only these parameters, with the connection string and the queue, and you're ready to go and start this action. Okay, for sending the message, we're making a for through the array. So we're going to send one by one all these items, and here is the message that I talk about. And you only have, I think, one option, well, two, and you're going to have this byte encoding. So remember that the protocol connects through binary data, so you need to make that encoding on your message. We do a little console write to see that this is passing from here. And then with your instance, you execute the send async message, and for that, your cover and your message will be arriving to the queue without any problem. That's for one side, and let me show you now the code for the receiver. It starts the same as the sender. You need the connection string, you need the queue name, and your interface. The difference here is that your receiver needs to start listening to the queue in order to see or to listen and pick new messages. So this is an example how you can create that listening process. And yeah, this is some default values that you can connect with the queue. And then you need to register that handler, and you're going to pass a callback, a function, a method that is going to process the message that it's going to receive. So here is a simple example. We are going to print the message that the queue has, and then we're going to complete that process. Every time the process is complete, in this case, the receiver will remove the message from the queue. You have insert scenarios. You can put again the message in the queue again. So that will depend on your specification. And Also, we have some handler in case anything fails. So we have a backup plan. And yeah, with those setups, you're ready to go. I wanted to to show you how this works. Let me start up the project. And the main key about, also there's a lot main key, but another thing that is important here and for Service Bus is that all the scenarios must be asynchronous. And I wanted to show how we can send a message. We're going to see that in the queue. And the receiver is turned off. We don't have any. This is not available at the moment. So I wanted to show that that behavior. So let's start with the sender and let's play start. This is building. Okay. We have here a program, and here is sending the messages. Also remember that all the queues are going to, all the messages are going to store in the queue, and when they pick up, there need to be, they are going to be in order. So we're going to have this same order that we send when we pick up the message. They are not going to be mixed. So we send all the messages. Let's go back to the queue. And here we have our 5 messages that we just sent. The current size of the queue increased because we have some data. And yeah, we have a lot of space because they are really, really light. And you have here some graph. This change according to the messages. So yeah, I'm going to stop this, and now I'm going to change project and go to the receiver and see how the receiver will pick up all the messages. So let me bring this here. Yeah, now everything work correctly. The receiver pick up all the messages that the queue has, with the same order: Programs Week, Go Beyond, Cognizant, Softvision, Azure Service Bus. And if you return to the queue and we hit refresh, the messages will be gone. The current size will be 0 because now we don't have any message. And that's it. That's a simple flow in scenario with queues and messages. So that's for one hand. So let's go back to the presentation. And let's talk about when to use Service Bus, because we know there is a very powerful application, but not application or not all services are good for all the situations. So let's check that in details. So when can I use Service Bus? Well, if you have some messages to send, that's kind of like really obvious. But if you need to send messages through applications, or you need to maintain data or connect different flows, it's really good to use. Also, when you want to decouple your applications, and here you can also take advantage of the asynchronous operation, because you don't need to have your receiver or your sender 100% online. So you can take advantage of that when you decouple the application. In the example, I added the two projects in the same solution. You can have it in separate solutions. There's no need to have it in one. So that is really helpful to make this the couple thing. Load balancing. This is a, something that also Azure brings, because it will help you to balance the workers and all the resources that you're going to have for connect your applications. When you have some scenarios that you're going to have some topics of subscription, so when you have some relationship between one and n parts, that is a really good time that you can use Service Bus. One example that I think is really clear for this is when you have, I don't know, Instagram stories that you post your story, your picture, or short video. In that case, the video, the image will be your message. You will be the sender, and when the receiver is ready or hit your user icon, it can pick it up that message and see. That is a good example in this occasion that use this topic and subscriptions, and also the asynchronous functionality. I don't know if Instagram use Azure Service Bus, but it's a good example to mention here. Also, there is when you need to check, and when you need to follow the message through all the steps. Maybe you are connecting different flows. Another good example for this is purchase flows that you make online. For example, you buy something, and then you can queue the purchase order of the client in one queue, and when the credit card or the payment is done, you can start to moving the message through all your flows. But for that, you need to have first, you don't have to lose any message, and also you need to know the state of the messaging through all your flow, right? So that is a good thing to use in with Service Bus. And also, if you have to have a session, if you have to maintain some session in the messages, you can do it here. You can have that feature with Service Bus. And to mention a few examples of when you don't have to use Service Bus, or it's not convenient at that time, maybe when you are implementing a login. Since you want to log in, you enter your password, and you want to enter the application fast. There is no point to implement Service Bus in this scenario. You need to find another proper application for that. I mean, you can do it, but it will not be a really good option. And yeah, to summarize and leave some room to the question too, let's see this little conclusion. So Service Bus is really good to load balance your work across competing workers. This brings together all the points that we talk and we see with the protocol that can balance the messages and have a very performant solution for connecting all the components, and also with Azure that you can scale your program according to your needs. You also have safely routing and transferring data and control across services and application boundaries. Here again, the protocol brings you a lot of tools to keep track of the message and don't lose any. Another thing that a Service Bus has is that there is no way that you can lose any message, and in case something went wrong, or for example your message expired because no one picked it up after the date you set, there is another queue that is called dead letter. So it's going to store all the messages that went wrong, or or no one pick up. So every time in each stage, you can keep track of your message and see what is going on during your communication. And then last, coordinating transactional work that require a high degree of reliability. Well, this is related to the point I just said. This protocol is really good to not lose any message because sometimes when we implement this, for example, in the purchase flow, you don't want to lose any sale or any package or anything. So it's really good to not lose any of the message and keep track of everything. I think I cover a lot of things, and I will give some minutes for any question that if someone have. So let me know if you have any question or you want to take another look on any slide of the presentation or the code. So